Hello class, welcome to the next segment in lecture 17, and in this segment we're going to start taking a look at some of the oscillation patterns that we introduced in the previous segment, and in this particular segment we're going to heavily focus on the El Nino Southern Oscillation pattern, how exactly that works, and what sort of impacts it has around the globe. So with that, we'll go ahead and dive right into it. So the El Nino pattern, or the El Nino Southern Oscillation pattern, is primarily concerned with what happens in the equatorial regions of the Pacific. And usually we focus on what happens off the coast of South America, but to some extent we also look at what happens along the coastlines of Oceania in Australia, which is farther west of South America. And typically what happens is you have an easterly trade wind. That is a wind that's going from South America to Australia. It's going from east to west. And something that you'll take a look at when you'll get into the mathematics of this when you take radiation climate in your senior year, but you can show that when you have this trade wind going from east to west, you tend to have upwelling of water occurring over here and downwelling of water occurring downstream of the wind. So upstream of the wind you have upwelling of water, and then downstream of the trade wind you've got downwelling of water. And this whole idea of upwelling is basically you're taking colder water, which is deeper into the ocean, and bringing it to the surface. So on the normal pattern, you have this east to west trade wind, and you're bringing this colder water up to the surface. So that's tending to cool the coastline, the western coastline of South America. And you're also bringing warmer air from the surface, or excuse me, warmer water from the surface over towards Australia. So you typically get cooling effect on the western coast of South America and a warming effect on the eastern coast of Australia. And in fact, those of you who are pretty avid beachgoers may have also recognized this. If you go to some east coastline, or to some extent the Gulf of Mexico, those waters tend to be a lot warmer than, say, a beach that's on the west coast of a continent like in California, where the waters tend to be a lot cooler. And the main reason for that is because of this trade wind pattern, where you have warm waters going along a coastline, along an east coastline, and typically cooler waters along the west coastline. And you'll talk more about the specifics of this in the radiation climate class, which will again be in your senior year. But in a typical pattern, we have these trade winds that are causing some upwelling of colder water, which means we're bringing colder water from the depths of the ocean up to the surface, and also to some extent downwelling. But during an El Nino pattern, that trade wind from South America to Australia weakens. And when you weaken that trade wind, then the amount of upwelling that's occurring is weakened, which means this cold water from the depths of the ocean, not as much of it comes up to the surface. So that means you end up with warmer water at the ocean surface off the coast of South America, and to some extent cooler water off the coast of Australia. And this is usually what you look for when you're trying to find an El Nino pattern, is you'll see these anomalously warm waters in the equatorial regions of near South America, and you'll typically have cooler waters that occur in Australia, but typically what you look for is the waters that are warmer than normal in the equatorial region of the South American coastline, the western South American coastline. And the opposite of an El Nino pattern is a La Nina pattern. So in an El Nino pattern, the trade wind weakens, and in some cases, the trade wind can actually reverse direction. So in some cases, in some rare instances of a really strong El Nino, the trade wind can actually go from west to east. But typically, it's just a weakening of the east-west trade wind. Now, for a La Nina pattern, that typically results in a strengthening of the trade wind. So now, instead of a normal trade pattern, when you have some upwelling of cold water, this really strong trade wind is going to upwell even more of that cold water found in the depths of the ocean. So the strengthening of trade wind results in more cold water coming up to the surface than normal, and this also results in more warm water being blown over towards Australia. So that results in anomalously warm waters off the coast of Australia and anomalously cold waters off the coast of South America. And the impacts of this pattern do in fact extend all over to the world, but probably you could make a good case that probably most of the impacts do concern themselves mostly in the continents of Asia, Australia, South America, and North America, because those are the continents that border the Pacific Ocean where this pattern occurs. But also, I mentioned in the previous segment how most of these oscillations patterns have a positive phase and a negative phase. The El Nino pattern is considered to be the positive phase, and the La Nina pattern is considered to be the negative phase of the oscillation. But in the case of El Nino, where the upwelling of the water is weakened, that cold water that occurs in the depths of the ocean is full of all sorts of nutrients that the fish enjoy. So if you bring that colder water up to the surface, the fish will go with it, and then you have fishing boats that can then catch the fish really easily. But in the case of El Nino, where the upwelling is weakened, that means the fish don't go up to the surface as much. They stay deeper down into the water where the fishermen can't catch them as easily. So if you've got an El Nino going on, you've got nutrient poor waters that are primarily focused around the surface, which means fewer fish, which means your fishing industry is not going to be doing very well. Versus a La Nina pattern where the upwelling is enhanced, so you're bringing more of that nutrient-rich water up to the surface, which means you've got lots of fish, a lot more fish than usual coming up to the surface, which means the fishing industry is living large. It's doing really well. You're catching all sorts of fish, selling them in the market, and the economy does really well. In fact, a neat little tidbit about El Nino is this particular oscillation pattern was discovered by looking at fishing records. So those countries that are in the equatorial region of South America, they discovered this pattern. They noticed some years the fishing was really good and some years the fishing was really bad. And in doing that, they were able to correlate that with the temperature data, the sea surface temperature data, and discover this El Nino southern oscillation pattern. In fact, one might say that they used a very efficient methodology to discover ENSO. I will see myself out after that really awful pun, but not until we get finished discussing what's in Lecture 17. Another impact that arises from El Nino is you have these anomalously warm waters on the coastal regions of South America, and that will lead to, that typically results in higher than normal rainfall totals in parts of the northern sections of South America. So that'll impact portions like countries like Colombia, Ecuador, and to some extent Peru. And this can be especially disastrous because you have the Andes mountain range, which is also pretty close to that region. And if you've got heavy rain occurring in the mountains, you can have some very serious flooding problems, not just from the rainfall, but also from rock slides and mudslides. If you get conditions that are sufficiently rainy and sufficiently wet, you can get all sorts of damage caused by those heavy rainfall amounts. Versus the opposite case, where if you've got cold water, then you're going to be experiencing probably what will more resemble a drought condition as opposed to an anomalously wet conditions along the coastline. And since you've got, in the El Nino phase, you've got colder waters near Australia, that means Australia is going to be dealing with the drought, while the coastal regions of South America are going to be dealing with the anomalously wet conditions. So not only is your industry not doing well, you're also getting flooded. So El Nino is just really awful if you're in that particular region of South America. But in the case of El Nino for Australia and also some of the surrounding island chain, which collectively is usually referred to as Oceania, since you've got cooler waters that are cooler than normal, that will typically result in drier conditions, or even to some extent, you can have some pretty severe drought in Australia when you've got an El Nino going on. Contrast this with La Nina, where you typically have that warmer water off the coast of Australia, that will result in anomalously wet conditions. So you'll have more rainfall than normal, typically in a La Nina phase. And another interesting thing that happens with El Nino is you get these anomalously warm waters in the East Pacific, which could lead to a more active hurricane pattern in the Pacific Basin. So that means more hurricanes and also more typhoons if you're, say, talking about the Central Pacific or parts of the Western Pacific. But another thing that this does is it actually shifts the jet stream so that the jet stream, the subtropical jet and the polar jets, are much farther south than normal over the continental United States. And that also extends into the southern half of the Atlantic Basin. So during an El Nino year, you'll typically have a really active Pacific storm season that has more hurricanes than normal in the Pacific Basin, and you'll have a relatively inactive season occurring in the Atlantic Basin. And then contrast this with La Nina, you have colder waters in the Eastern Pacific, which will tend to suppress tropical cyclones in the East Pacific. But another thing that La Nina does is it does the opposite thing to the jet stream as well. It pushes the jet stream farther north over the continental United States and over the Atlantic. And something that we'll talk about a little bit later on when we talk about hurricanes is if you've got the jet stream over these warm waters, you're introducing a lot of wind shear into the atmosphere, and hurricanes really hate wind shear. In fact, they're very sensitive to it. That's one of the reasons why hurricanes primarily form in the summer months, is that's because the wind shear is typically weakest in the late summer and early fall because the jet streams are so far north. But the jet streams are even farther north than usual, then you've got even less wind shear in the Atlantic basin, and that can give you a more active than usual hurricane season in the Atlantic basin. In fact, 2005 was a pretty pronounced La Nina year, and that turned out to be one of the most active Atlantic hurricane seasons on record, if not the most active on record. I think there were 28 named storms in that 2005 season, which is insane. There's a lot of tropical storms and hurricanes forming in that particular La Nina season. And again, since that jet stream is displaced further south over the continental United States, that can also lead to anomalously wet conditions in the south. And one of the best examples of this was the 2015 flooding event that happened in the Southern Plains in the month of May, where you basically had 2 weeks of nonstop heavy rainfall, and some regions picked up, I think, 30 to 40 inches of rain during the month of May, which is pretty ridiculous. That's very unusual to see in the Southern Plains. And if you've got a jet stream that's displaced farther north in the case of a La Nina phase, then you're going to have typically going to have drier conditions in the south and to some extent wetter conditions up north in the northern United States. Another interesting thing about the way that it displaces the jet stream, the El Nino phase typically results in cooler than normal conditions in the southern half of the United States, and believe it or not, warmer than normal conditions in parts of the northern United States. And La Nina flips it around. You typically have warmer than average conditions in the southern United States and cooler than average conditions in the northern United States. And one good example of that was the 2011 summer. 2011 summer was a La Nina summer, and boy, was that summer brutal in the southern United States. There were some, I think that was the year where I think it was Dallas-Fort Worth. They recorded 71 triple-digit days, which was a record. That was a yearly record, and the 71st day occurred in the middle of October. Or no, it wasn't in the middle of October. I think it was at the end of September. And that was also a year where Oklahoma City Airport, I think, recorded a high temperature of 111 degrees, and it was really humid outside. The heat index was ridiculous. So it was really miserable to be outside during that 2011 summer. But again, that's one thing that La Nina can do. And this is something that I kind of already alluded to. If you're looking at the plains weather patterns, El Niños are typically more conducive for flooding events in the plains. So you typically get a lot more rain in the plains during an El Nino phase. And during a La Nina phase, because you've got these warmer than average temperatures, that typically means you have a larger window of opportunity for severe weather events. And in fact, the 1999 severe weather season arguably began in January, and it was anomalously warm. And of course, another notable event from 1999 was, of course, the F5 tornado that went through Moore in parts of Oklahoma City. But also another good example was again, that 2011 year where you had the most active April on record in terms of the number of tornadoes. And of course, the April 27th super outbreak occurred in the southeast. That was also during a La Nina phase. So El Nino typically associated with more flooding events and severe weather events in the plains, but during a La Nina season over the southern United States, and to some extent the southeast, you typically deal with more severe weather activity. So that's going to do it for this talk on El Nino and La Nina. And so that's going to do it for this segment. And the final segment, we'll talk about some of the other oscillation patterns. We won't go into as great a detail, but we will talk about the mechanisms behind it and what sort of impacts that they have. So with that, I will see you all in the final segment.